Right, here we have a vectors problem where we have a 32 Newton block which is stationary on an incline of 15 degrees. And the question's asking what are the magnitude of the forces acting parallel to the incline and perpendicular or 90 degrees to the incline. And it looks kind of tricky just now, but the first thing that really helps is drawing a free body force diagram. So to start off with, draw your free body force diagram on the block, put in any numbers you have. So we've got 15 degrees here, a weight of 32 newtons, and we're really looking to identify the other forces, which in this case are friction and normal, which is acting parallel to the incline and perpendicular to the incline. After that, it's really a matter of finding the value of these components. Now, there's a couple of different ways to do this. First of all, it really helps if you draw out the components you're looking for, but a quick tip is to rotate the whole diagram or turn your head in just a simple matter of 15 degrees. So now we can figure out what the components are perpendicular, that will be equal to normal, and parallel, which will be equal to friction. So a little trick there is just turn your head to the side so that you now have only one vector which is acting at an angle, and you have two which are acting along the what would be the horizontal and the vertical here. Okay. So this is the stripped down diagram. So we've got 32 newtons acting downwards at weight, and if we rotate it, we end up with 32 newtons acting at an angle of 15 degrees right here. Okay. Now, this is basically a trig problem. So that blue triangle are the same as this blue triangle. So we're at we've got 32 newtons, which is acting at 15 degrees to the vertical. After that, it's just a matter of finding the two components of weight. So this component here, which will be equal to friction, this component here, using trigonometry, SOHCAHTOA, we have the opposite here, and we have the hypotenuse here. So it's sine of 15. This gives us 8.3 newtons for that. Then this component here, which is the adjacent, will be cos 15, which will be n over 32, which gives us 31 newtons. And there we